There's no laws that say those ankles have to do the same thing. You know, you can have one can plantar while the other can dorsal. And there's some pelvic girdle stuff and other things where there's no choice. One has to do the other. So as an example, you know, if I say, hey, what's happening in my hips? And you just say, oh, I know that's ab and adduction. Which one is which? That doesn't allow me to assess if you knew which one is which, right? So that's the important side of joint and motion, especially when we have a lot of joints that flex and extend. I didn't teach you this, but I think we played this game long enough for you to figure this out. Toes are kind of like fingers, and they follow the same rules, getting us in the fetal and getting us out of the fetal. We could go straight up elbow nerve, or it's going to say metacarpal phalangeal, interphalangeal, but I don't want to play that game. This is going to say fingers and toes. So what do you think the toes are doing when that person goes up on their toes? Do you think those toes got further away? Yeah, they got further away from that. And that's how this Navy's put it. I didn't have to sit there and measure some eagle. I could just say, are those toes further away or closer to fetal? And we know that this is an inflection of the toes. So this is the inflection. Kind of like when we're doing the push-up in the wrist, right? This would be the reverse of my toes from here. So coming back down, right, left, that would be bilateral ankle joints. Dorsal. I think a lot of students miss that because it's not traditional dorsal. It's not bringing the foot up, but you got to have it. So let's say like a full range of motion might be like here, there, here, there, here. And I think those are all scientific terms, there and here. Plantar from, dorsi to, dorsi from, plantar to, plantar from. How about this one? Box simple here to that's not it. So going down, so let's say she starts with her lower extremity in anatomical position, I like the shoulder. Okay. She goes down to that position. Remember, guys, Campbell is not here to tell you how you should do anything. I'm here to just tell you what's happening. Sometimes maybe you're going to use that form. That's your world pixie. I'm here to tell you what's moving, whether they use good form or bad form, whether it's pretty or it's ugly. It is what it is, okay? So I'm not here to debate form. I'm just here to debate if her legs start straight and she goes down, what happened at her knee or side flexion? Nice. Goes back up, plantar flexion. Goes up on her toes, more plantar flexion. That's the whole point of giving the whole to and from. That sometimes students will say, well, how can it be both plantar when she comes up and then goes up on her toes? And I'm like, because you got more room in the road. You travel further in. There we go. How well is so let me ask you this and help me help you if this is your question or not. That's not your fault. It's not fault. I'm not understanding. Is she an anatomical in the photo?
Yeah, whenever she stands, are you talking about she gets up and she goes up her toes, or she just gets out and talks?
So she goes up starting from that position. So if we agree that she's not an anatomist, the follow-up question is, well, what is she in? Where are her brain goes up? And when she comes up and has straight legs, in front of the
That's something to say, you know.
the motion would, yeah,
Okay.
because the only way to go when the those flies to be anatomical is that kind of funny.
Okay, so that's all good.
No problem. The main thing is we want to make sure we don't think nothing's happening if it's. Does that make sense? We just want to make sure that we don't attribute no motion, because all we've ever learned or been taught is this. But I mean, we have the same thing with this.
So you said like she's saying to
She's your side flex. I mean, you did it.
no, I mean,
And you know why that's important? And I know that may not even be what she meant, but it's so important because I have no idea how she's moving, right? It's just a picture. She could continue, she could be going down. She could be coming up. The eyes could be coming up, or she could be not moving at all, right? She could be, well, this position. So if she's not moving at all, how can we say she has dorsiflexion or plantar flexion? I mean, since there's no motion. But what we can say is she's dorsiflex. And that counts with always could be she's dorsiflex where it's going down. Up. See. Does that make sense? Position, where are you at? Motion, how are you? Kind of. So yes, she is dorsiflexed, but we have no clue she's dorsiflexed. Just like we know I made clue if she's plantar flexed. We have to have a context, like the before and after. Or hey, she's coming up, she's going back, right? And I mentioned this several weeks ago, but I need to remember, I mean, to each with repetition, because it's unfair that I say things one time. I shouldn't ask my voice. You may say, well, yeah, well, how is this even fair? Because, the real world, we have live action video. And on the test, you're given these pictures. The answer to that is that's what real life video is. Say, flip book with still pictures. Now you have more pictures, crossover. But your brain doesn't see live action, it's seeing a sequence of fixed pictures that your brain then does a flip book to. For example. Okay. And not only that, but our brains are not 100% accurate when it comes to certain things. And our brains play tricks on us. Optical illusion, those darn magicians, always have the upper hand. So if I can teach you and things that happen fast in a game, my athletic trainers, you're going to have to, as best as you can, see mechanisms, manipulate, those things happen fast. And guess what? There is no rewind when those things happen. On stop. So the best I can do is teach you these kind of frame references. Where is it at? Where did it go? Where are they at? Where did they go? How did they start? How did they finish? Is this being helpful?
so you said from the squat, just standing up, just plantar flexion. But when she's standing up, she still goes to flex. Is it palatable? Or when you're hands off, you're not going to flex.
Okay, but there's a reason. And it's the biggest reason. And when I say it, you're gonna be like, oh yeah, I think I remember him saying, or you may not, it's all. I may not say it. So I think there's only a few joints that when they're anatomical, they're at the end of their road. The elbow being one of them things, and the knee being the other. And so what happens is because the elbow and the knee are at the end of their road in anatomical, we can say that they are in an extended position. But the wrist isn't in an extended period position in anatomical because I have tension from anatomical. The problem I think that gets confusing is because extension beyond anatomical damages the elbow and the knee, hyperextension. That bad habit gets people thinking any extension from any joint has to anatomical type. Does that make sense? So the fact that I can plantar or dorsi from anatomical means I can't be dorsiflex in anatomical because I can keep traveling down that road from it.
So when we're anatomical, you can call anatomical. Okay, where's my?
So we would be extended with anatomical. Why? It's painful further. And we're gonna learn there's some other things, like your radio, supine radiated anatomical. Why? And only further. But not every joint is in a position that is simple. You can go to or from, and you can't be either or. Here's another analogy. I don't say my trunk is in an extended position. Why? Because I have extension. But let's put it to frontal because I think this plays better. I can bend to the right or I can bend to the left. Sure. So if that line of reasoning, which is ridiculous, but I tell you why it's that because of the injuries here and there. If the line of thinking is, well, one has to be the position. How do you pick right bent or left bent is anatomical? In other words, if I can bend to my right or bend to the left, how do I pick which one I am at in anatomical? Well, I'm right bent and anatomical on the left side. Why aren't you saying left bent? Does that make sense? It's very simple. I can have flexions, I can have extensions. So I can't just say I'm extended and anatomical when I can actually travel down that road with normal range of motion. Or here's another way to say it. Right lateral bend, left lateral bend, hyper left lateral. Left, right, hyper right. So it's a common trap. And I think it's because some of the most damaged joints in the body happen to have hyper from anatomical. So that's just because they don't move any further in that direction. Question. Okay, while we have this photo, because it seems to be popular, let's go ahead and do knees and hips while we have it up there, okay? So give it some thought, don't answer right away. Ask your neighbor or ask the different personalities in your brain. Father done. Halloween season. Does anybody have any younger siblings, cousins, children, and during Halloween season, and some of those previews to some of these crazy stuff? So like, not now, my boys are old enough. Back in the day, we used to have that little football, quick crawl. Some of those previews. Like, Mom and Dad, can we see if you're gonna have a catch light? No, where are no one, please? What's happening at the knees if she goes up?
Says you sleep 5 hours and then he says sleep on.
No, it's but it's developing good habits. It's developing good habits. What about at the hips? bilateral spacing. Pelvic girdle is a tricky one for squat. I wouldn't ask it on a test. Bless you. And the reason is because although the hips want to pour water out the right side, the knees actually are compensating that by countering it for water out the back. And so what you have is kind of this initial anterior tilt, but then as you go down, it flattens out. Does that make sense? Because again, if I just stood here and flexed my knees, I'd pour water out the back. So you kind of have this, we call it simultaneous movement in biomechanics. You're gonna learn this. But I wouldn't ask for pelvis in like a squat because you have one thing trying to tilt it forward, but another thing trying to tilt it back, and they kind of cancel each other out. Yes, ma'am. The hips are not an anatomical right there. The hips are flexed. They are more in the doesn't. I can try this one.
So I'm thinking about the position of,
Ah, yeah, yeah. So the pelvis would be, I'd say her pelvis would probably be just minorly tilted forward, but that's because if all she did was flex the hips, but she's also flexing the knees, and that's what brings it back. Does that make sense? So fair questions on the test is stuff like this, but I wouldn't ask a question where the hips are trying to pour water out the front, but the knees are trying to pour water out the back, and they cancel each other out while you go up. There's a term, and do not write this down. Forget I even said it. There's a term called pelvic girdle translations that can happen where you have things that are actually trying to spin the pelvis in different directions that can work together to kind of translate it forward, allow it to kind of translate down to the back or to the side. There's certain joint motions that can happen to cancel these things out so that you can shift. All right, speaking of, let's do this. Let's do. Is this good review? Is this being helpful? Good. All right, let's do something like this. Can everybody see the top right photo? Okay. All right, give it some thought. I want you to, as of right now, answer the pelvic girdle rotation. If the answer is no, you're done. If the answer is yes, we got to say what is responsible for it. Remember, if we have pelvic girdle rotation, we got to say, okay, well, the basketball spun, great. How did it spin? What spun? Is it the ends below, or is it the ends? You thought. If that's thought with your neighbor or yourself. sciences, so things they were. Charlie Sheen. I used to have, when I used to go to visiting investments for the yanked up and go to this area. He felt it down from where it's 13. So sometimes I was glad and be my power. What? There's a need. This is yes.
Was it most one such star?
Yes, sir. Question then being top to bottom, did the pelvis rotate? Yes, yes, no question, good, the answer is yes. If so, how? Anterior spin. If you're a water blower router, no problem. Just think the top of the pelvis is still the top of the pelvis. And if gravity was going this way now, it would still pour water out its front. Anterior spin, anterior pour. Okay. What caused this? Was it the trunk flexion or the hip flexion? One of those answers is correct. It's either trunk or, let me ask you this, let's do a thought experiment and see if you change your mind. Could she do crunches at the top and just flex her trunk? She could, right? Does her pelvis have to go anywhere when she just flexes her trunk? What must happen to make her pelvis rotate anterior?
So the face right?
Yes, sir.
So,
Yes, yes. What a great question. Just because her hips are flexed doesn't mean they're all the way flexed. So let's look at it like this. Elegant question, great question. Well, the hips are more flexed at the bottom. And that's why we can do things like range of motion or she's flexed, let's estimate maybe about 40 degrees from the bottom, but then when she comes up, they're flexed even more. They're more like 65. So she just had more flexion.
So it's bilateral. Doesn't bilateral place. Yes, sure.
Here's another thought experiment. Once she's up, once she's up, she could totally just extend her chest. I don't even look silly. But I mean, she could totally be like, what's the Taylor Swift move or whatever. Like the little meaty little girl. Like she could totally extend her trunk and the pelvis doesn't have to go anywhere. It's only until she extends those hips that the pelvis is going to go back. Does that make sense?
No, this is like too nitpicky, looking too long.
Big away.
If you said, since they're both biased, her hips, would it be flexion to flex?
They're both flexed, but she has flexion to go more flex.
Okay, so is that something that you could ask
It's
this?
100%. But let me give you a real world analogy. A real world analogy to kind of say what I'm trying to say here. Lafayette is home. I know it's not home to everybody, but the university is here. What I'm saying in this example is you are in Breaux Bridge, which is east of Lafayette. You're east at the top. When you get to the bottom, you are in Baton Rouge. You're still east, But how did you move to go from a little east to more east? You had to travel in the direction of east to go further. So that's what we're talking about here. Yes, you're flexed in both, but you're more flexed on the bottom. And the only way to go to being less flexed to more flexed is to have right. The only way to go from being more flexed to less flexed is to have extension. And that's why we spend so much time. I'm seeing some light bulbs go off. That is what I love. That's why I do what I do. It's why we spend so much time on the difference between position and motion. Because you can still be flexed, but yet be extended. Have extension. Nothing wrong with that at all. That's like this. I start here and I do this, and then I come down. Maybe you don't want to go all the way down because you want to keep tension maybe on your shoulder muscles, right? So you start in a flexed position. You have flexion to go more in a flexed position, and then you have extension to go to a less flexed position. In all three, you're still flexed. We're good? Hey. Talk to me about the position of his right hip. See if you can find enough context clues there. First thing I would do is say, where's the pumpkin looking? Or where's the penguin? Where's the penguin looking? Would the penguin be looking, and when I say the penguin in the pelvis, right? Or the pumpkin in the pelvis. Would the pumpkin be looking at us? Or would it be looking like at the picture? Good. Now, his toes of his right leg is straight, right? Are the toes, if he's facing, let's say the front of class is the picture, and we establish that his pelvis is facing the picture, are his toes also facing the picture? His toes are kind of facing in, right? More medial. So what position is his right hip? Is it internally or externally rotated? This is not a question, right? It's a good question. Stand up, everybody, if you're willing and able. Is he a right-handed batter or a left-handed batter? Left. All my baseball people like, playoffs, yes. All right. So he's a left. This is going to look weird because even though I threw left, I'm batting right. So he's left. So we want to look at our right shoulder. Everybody look at your right shoulder. Okay? Now, we're going to take our pelvis and rotate it in the transverse plane so that it can see the picture. Because obviously, go back to anatomical. If you're looking at your right shoulder, you're looking at the picture. True? So I want you to rotate your pelvis so that now your pelvis can see the picture and see if you can see how your hip is rotated. Is it internally or externally rotated? First of all, how would your pelvis have rotated to see the picture? Right transverse. Yes? Now the left hip doesn't count because that's a kickstand. You know, like you have a kickstand on a bike to keep the bike from falling over? His left hip is here so that he doesn't fall back. The rotation is occurring about his lead leg for optimal spin. That's why a figure skater doesn't spin on two skates. A figure skater that's trying to spin goes on one skate. That's the sound they made. Right? Right transverse because of right hip internal rotation. he is internally rotated and it's right there. You can be seen. Or you could stay standing, doesn't matter to me. Because you got what? Oh, gosh, that's okay. I will not tap in your hand that you just said. And that's why I would hope for a different picture. I mean, I just kind of do something and I was here to kind of try to guide us through the process, but I would do something that would be less ambiguous. I think it's my opinion. Yeah, a lot. If you're, so whenever he's pointing his foot towards the picture, then he's doing the steps to be sure. That would that be? Yeah. So what's gonna happen is when he's here and he does this, eventually you're gonna run out of road. And this is gonna happen after you run out of road. Alright. So in other words, to generate the rotational forces, your feet kind of have to interlock with the ground. But then once I run out of range of motion, then I can take my foot off the ground and then it can go along to the rock. Okay. I guess I was talking more about the figure picture is that. Yeah, he's internally rotated. And we can see proof of that, like all through his leg, like this. Like his, now, right when at that photo right there, he's starting to run out of real estate. But if his hip was an anatomical, he would be here. And that is because his rotation is actually at an angle. He's not doing like T-ball players and doing this, right? We're doing like a figure skater. We're passing through a lead leg so that we can have optimal rotation of our whole body. So the true illusion here, and again, I screw something up here. I would hunt for a better picture. The real purpose is so that you don't, regardless of if we're hitting or regardless of if we're just changing direction, the true purpose is for you not to say external just because I see or feel something going lateral. Because you guys were probably introduced, and they're not wrong, that this is lateral or external rotation. But when the socket moves about the ball, that is not lateral or external rotation. That is internal rotation. That's really the thesis of this conversation, is not just to say the hip is rotating laterally, even though it may look like it is. How about one more while I got you here? Is that cool? Okay, Jay Nelson. Yeah, I think on that one, but I don't know, man, that looks sketchy. Wow. That it kind of looks like one of my little ostrich drawings, actually. Okay. I think it's pretty cool, because especially to have like the little lines or so they look to. Let's see if I can save this, and I'm gonna pull, since this will be our last one, I'll pull it up. Guys, I know I usually let you guys out a little early in case people have questions, but I feel we're making some progress here, okay? So I want to try to, I'm selfish, I want to try to, all right. So here's the question. God, it looks like a Star Wars TIE. He starts off in anatomical, so he starts off 11. And he finishes in the position in the third. So he goes there. Right? Pelvic girdle rotation, if yes, what from? Don't talk, we're not gonna have a conversation about the trunk. So I'm giving you that answer so that we can get to the root of the hips, okay? From his perspective, not yours. Here to there. Do we agree that his pelvis is pouring water out his left side? Yes. Left lateral pelvic girdle rotation. Because of what? Left hip ab, right hip ad. Good? Absolutely. From here to there would be left lateral pelvic girdle rotation. Whether you think of it as spin, the basketball would spin to my left, or whether you think of it as pour, the water would pour off to the left. Left lateral because of left hip ab, and right hip ad. This is where my hands will represent an imaginary anatomical. What if my hips were able to stay in anatomical? And then you see the motion that would have to happen to get me here. Start, finish, ab, ad. Cool. If you believe in prayer, say a little prayer for my father. Thank you. Have a good day.